Jai Hind everyone. I'm Sheradha Jauhari, Assistant Professor IT Department in AKGEC Engineering College. Today I'm going to take another complex topic from the first year subject Programming from Problem Solving, that is arrays. So in today's lecture, we are going to cover array, types of array, which are 1D array and multidimensional array. So first of all, what is the need of array? So till now, we are working on the simple variables. Whenever we want to store any data within the computer system, we always declare a variable. For example, we are taking integer a. Integer a is declared, and within a, we are allocating any value, that is, let us assume 10. Now, if there are multiple values which are to be stored, which are to be used within the program, then what? We will take multiple variables. If I want to store 10 numbers, then I require 10 different variables, which is a very tedious task. So, as the data is increasing, number of variables will increase simultaneously. So, to stop this, the better way is to use array. So what are arrays? Arrays are the collection of similar data type. Means if we have a data of same type, in that particular case, instead of declaring multiple variables, we can declare a single array and store multiple values within that array. But the constraint while using array is that all the elements which are being stored in the array are stored in contiguous memory locations. So we can say that arrays are nothing but these are derived data types. So whenever we want to store multiple values of same type, we always prefer array instead of declaring multiple variables, because it will increase the complexity of program and it is very much difficult to memorize each and every variable and the purpose of the variable. So how to declare an array with a program? The syntax for declaring an array is data type, array name, and the size. For example, if I want to store 10 different integer values in a program, in that particular case, an array is declared as int, that is data type, because I want to store 10 integer values. So data type is int, a is the array name, and 10 is the total values which are being stored within that array. So, how the array will recognize different variables, different elements? By the various index values. Whatever value is defined within this size is the index. So, here this 9 is index number. So, how compiler will come to know that I am storing different values? With the help of these index values. The very first value is going to be stored at A0. The second value will be stored at A1. Third is A2 and so on till A9. The base address, or we can say the base index value of array is always 0 when we are talking about C programming. So in C, the initial or we can say the very first element is every time stored at the 0th index. That is why the maximum value is 9. So starting from 0 till 9, I can store 10 different values. So here, when I am using array, there is no need to remember multiple variables and data which is being stored in that particular variable. I can easily memorize a single name, that is A, and I know that within A, I can find 10 different values. But the constraint is all these values are of same type. Means all are of either integer, float or char. Any type, not the mixture of data types is allowed within the array. Next we have types of array. So in C we have two types. First is one-dimensional and second is multi-dimensional. In multi-dimensional, we basically focus on 2D and 3D arrays. So first of all, we should discuss one-dimensional array. So what are one-dimensional array? One-dimensional array contains one subscript. Means how the syntax will work: data type, array name and size. This, whatever value we are writing, we are providing within the square brackets is the subscript value or the index value. So any array which contains only one subscript or one index, that is known as one-dimensional array. Means any array name with one single square bracket. For example, int A10. This is the one-dimensional array. How this is going to be represented within the memory? Like this. For example, I have taken an array A, and these are the different values which are being stored in the array. So whatever we are writing within this square bracket is the position of element or the various index values on basis of which we are going to identify the different values. Because the name of array is same, so values are distinguished on the basis of the index value of the array, not the name of the array. Because name for all elements is same, that is A, but index value is different for all the values which are being stored within the system. Now this is A, which is the array name. Within the square brackets we are writing the position. As I told you earlier, the base index value of array always starts from 0. So here I have declared A10. It means the values will be initialized from A0 till A9. These are the data values which are being stored within the program. So when I am talking about the memory, the data is stored at the continuous memory location. There is no gap between the two elements. All the elements are adjacent to each other. Now how the array is initialized? For example, int A10, as in the previous example here, it is declared int A10. Now how to initialize values within this array? So values are initialized int A10 equal to, within the curly brackets, with the help of comma, you can write different values which are being required within the program. So within this example, I am taking different values starting from 1 till 10. So all the values are comma separated and are written within the curly brackets. So within the memory, starting from A0 till A9, data is being stored in the same sequence. In whatever sequence you are providing the data within these curly brackets, in the same sequence the data is being stored within the memory. As you can see here, 1 is stored at A0, 2 is stored at A1, 3 is stored at A2 and so on. So whatever is the sequence which is being provided during the compilation is being stored in the memory. Next, we can see this code snippet, how to initialize the array at the compile time. So, first of all, we have header file stdio.h. Next, within the main function, the first step is the declaration along with the initialization of array. So, int A10, which signifies that I am taking here an array named as A, which is of type integer and its size is 10, which means an array A is created which will contain 10 different integer values. How to initialize? Within the curly brackets, I have written comma separated 10 different values. Next, I have taken a variable I. Now printf elements entered are. As I have to print multiple elements, that is 10 elements, for that I need a loop. So within the for loop, if I equal to 0 till less than 10, what I am printing? I am printing A of I. So how this loop will work? For I equal to 0, printf %d A0 means it will print A0 and the value which is stored at A0 is 1. Next, I is incremented by 1, I is 1. So, value stored at 1 is 2. I is incremented again. Here I will receive A2. So, at 2 it is 3. You can see the sequence. The sequence is same whatever is entered by the user at the compilation time. So, the sequence will remain same. Now, what if user did not provide all the 10 values? For example, I have written A5 is equals to 1, 2, 3, like this. The size declared by the user is 5, but the values provided by the user is 3. That is 1, 2, 3. So what will happen in the memory? In memory, whenever as arrays are static in nature, a block of 5 cells is created. At A0, 1 will be stored. At A1, 2 will be stored. At 2, 3 will be stored. At A3 and A4, 0 will be stored by default. So whenever user forgets to initialize the complete array, in that particular case, zeros are stored within the array. It will not be the case that only array up till A2 will be initialized within the array. All the complete array will be initialized will be declared or created within the memory. But the values which are not initialized by the user are by default given as 0. Next, we will see how to take input from the user. So, when we are going to take input from the user, in that particular case, we need a scanf statement. So, first of all, a statement is there, that is the declaration of array and different variables I and n. A20 signifies that an array named A is created of type integer whose maximum size is 20. Now, I can ask from the user how many elements user wants to insert within the array, which cannot reach or which cannot cross the limitation of 20. So, a maximum of 20 elements can be entered by user as the size of array is declared as 20. Now, scanf %d n. N is the number of elements which user wants to enter. So, enter the elements. How we can enter the elements? Again, we will write the for loop, and within the loop from 0 to n, we will write scanf statement. Scanf %d and ai. What it will do? When I is equals to 0, %d will accept the value from the user and will be stored at A0 since I is 0. After that, I is updated by 1. Second time value will be accepted by the compiler but will be stored at A1 as I is 1 now. Again, as I is updated, value will be stored at A2. So, in this way, as loop will progress, the values will be stored in the contiguous memory locations. Now, how to print these values? Again, we will simply write for loop, and within the for loop, we will write the statement %d ai. This will print all the elements which are being entered by the user. Next, how to insert an element at a given position within an array. If suppose an array is already existing within the memory, as if we are having a list of elements and we want to add some element at particular position, then what we will do? So for this, first of all the elements of array are printed as it is. So within this program, what we are learning, we will learn if we have a particular element which is to be inserted at a specific position, in that particular case, how we are going to insert a element at that particular position. So the logic says, whenever we want to insert an element, first of all create a space for the new element. Because as we know, as we have discussed earlier, that arrays are stored at contiguous memory location. There is no gap or space between two adjacent elements. So first step to insert a new element at specific position is to create the space at the designated location. So for this, we require shifting of elements. So for example, we will see within the program, the first part of the program will tell you how to take input. So here in the left part of the program, what we have written, we have declared an array of 20 elements. We have taken multiple variables which are being used within the program. Now total number of elements are being asked from the user. Let us assume that user entered 5 elements. In this particular case, loop is run for 5 times. 5 different elements are being accepted by the compiler as loop is running for 5 times. Next, after inserting the elements, we can check how the elements are being stored within the memory. So after printing the element, now ask the user the desired element and the location which is being inserted. So first of all, position is equals to location minus 1. Because as we know that generally we always start counting from 1. But the constraint with array is the index values always starts from 0. So when I am talking about second position, the array will store that element at A1 because index value starting from 0. So that is why we have written position is equals to location minus 1. Location is the variable or the position which is being entered by user. So now position is nothing but the index value which is being represented by the array. Now for I is equals to n minus 1 till that position, what I have done, I have shifted all the elements. Ai plus 1 is equals to ai. In this way, all the elements are shifted downwards. Means if I consider an example, if I create an array of 5 elements. This is 0 position, 1, 2, 3 and 4. So at position 0, I have element 1. At 1 position, I have element 2. Now at this point of the program, user entered that he wants to enter number 10 and the location is 3. Location 3 means he is talking about the third position within the array. Third position signifies this particular position, which is being stored as index value 2. So position is equals to location minus 1 will make the two different values same. So position is equals to location minus 1. Location entered by user is 3. Position is equals to location minus 1, which means 2. So position is 2. Means user wants to enter new element at this particular position, at this particular cell. But we can see that this particular cell is already occupied by a number 3. So how to store number 10 at this particular place? If I directly place 10 here, then data will be lost, 3 will lost, because this cell will be overwritten by the value 10. So I have to save this particular data also and add a new element at this position also. So for this, if I shift all the elements one step downward, means if 3 comes at the position of 4, 4 comes at the position of 5, and 5 is shifted to the new position, in that particular case, I will have this place vacant and I can easily store 10 at this place. So for this, what will I do? I am starting the loop from n-1 till position and I minus minus. And what I am doing? AI plus 1 is equals to AI. Means first of all, this 5 is shifted to the new position. When 5 is shifted to the new position, 5 will come here. Next, 4 is shifted to this position. 4 will come here. Next, 3 is shifted to this position. 3 will come here. The process will stop. After that, A position is equals to num. Whatever value, num is what? 10. And A position is this particular cell. This particular cell is overwritten by a value 10. So, now I have written the values 1, 2, 10, 3, 4, 5. So, the length of array has been increased. So, at the end I have written n++, which will increase the size of array. So, after this, I can print the elements. For I equal to 0, I less than n, print ai. So, all the elements which are being stored after adding the new element will be printed after execution of this particular statement. So, in the similar way, we can delete the element also. But for the deletion process, what we have to do? We have to reverse shift the elements. Means within the same example, if I have this array 1, 2, 3, 4 and 5. I want to delete this element 3. So what is going to be the process? The condition is location must be greater than equal to 1 and it must be less than equal to n. That is, an array must exist. Then only we can delete an element from the array. Now shift all the elements one place upward. Means shift 4 at the place of 3, 5 at the place of 4. And decrease the size of array by 1. So here it is written, starting from the location less than n, what I am doing? ai minus 1 is equals to ai. So when this statement is executing, 4 is shifted to 3, 5 is shifted to 4 and finally n minus minus. Length is reduced. So finally, after doing the shifting process, what will I do? I will print the array. Now print the array ai. Clear? Okay. Now next we will discuss what are two-dimensional array. So within the two-dimensional array, we have two subscripts. As we discussed, within the one-dimensional array, there is one square bracket. In this two-dimensional array, we have two square brackets. One is for row and second is for columns. So, data type, name, rows and columns. First subscript is for rows and second subscript is for columns. So, for example, int a 2, 3. So, means how many rows are there? There are 2 rows and 3 columns. How this is going to be represented within the memory? Like this. A00, A01, A02. That is 0th row, 0th column, 0th row, first column, 0th row, second column. Similarly, first row, 0 column, first row, first column and first row, second column. Within the memory, in this way, data is being stored. Each and every cell will be represented like this. That is, now index values are 2. One is for row and one is for column. The data is being stored row wise. So whatever data you will provide for two-dimensional array, it is being stored row wise, not column wise by default. How to initialize? In the same way, that is 2, 5. But now as we have two different subscripts, we can separate the data row wise, or if we are not going to separate the data row wise, in that particular case, data is by default stored row wise. So it is your choice if you want to store or segregate data row wise. In that particular case, you know there are 2 rows and each row is having 5 columns. So within the curly brackets, you will provide 5 different values. So first 5 values are for row 1 and second 5 values are for row 2. So in this way, this is being initialized within the memory. Next, we have how to add two-dimensional array. Two-dimensional arrays are nothing but, in general terms, we can say these are the matrices which are being used in the maths. So we can declare as many arrays. First is A 5 5, B 5 5, C 5 5. That is, first array is A, second is B, third is C. A and B arrays are input array. How to take input within the array? That is total number of rows and total number of columns. So let us assume total number of rows are m and total number of columns are n. So within this, first outer loop is for rows and inner loop is for column. As we know, by default, data is being stored row wise. So whenever this loop will run, data will stored accordingly. Aij, initially I is 0, j is 1 to n. So 0, 1, 0, 2, 0, 3, 0, 4 and so on. So row 0 data is being stored. Secondly, when I will get updated by 1, row will become 1, again j will be changing 1, 0, 1, 1, 1, 2, 1, 3 and so on. So data will be stored row wise in A. Similarly with the B matrix, the same code is written. As we are taking input in matrix A, we will take data in matrix B. Next, how to add? We know for matrix addition, the formula is very simple. Within the third matrix, with the help of arithmetic plus operator, we can add two different matrices. So we have written the matrix addition formula here within the loop, and after that, in the similar way, within two loops I and j, we are printing the matrix C. So this is going to be the output. As we have entered the order of matrix 2, 3, that is 2 rows and 3 columns. So total 6 values are being stored. 4, 7, 2, 6, 5, 9. This is row 1. This is row 2 for matrix A. Similarly, this is row 1 and this is row 2 for matrix B. And the resultant matrix is row 1 data is being added and row 2 data is being added here. So I hope today's topic is clear to you. These are the reference books from which I have taken the content. We will discuss some other topic in the next lecture. Thank you.